I have a question over here. Now these are checked papers, so we're going to see how the students attempt their papers, and of course, what kind of mistakes are usually made by you guys. As you can see, October November 2023, and this is paper 21. Right. Just a quick read of this question. As you can see here, they say a hot air balloon floats just above the ground. Now the balloon is stationary. Now this is important. Okay, so we know that balloon is stationary, first thing, and it is held in a place by a vertical rope. Okay, you can see over here there is the rope. All right, now what next? They say the balloon has weight of 3.39 into 10 to the power 4 Newton. The tension T in the rope is 4 into 10 to the power 2 Newton, as you can see here, and there is upthrust, right, acts on the balloon. Fine. Now, what is the next part saying? They say the density of the surrounding air is this much. All right. Now, look at part A. They say on figure 2.1, draw labeled arrows to show the direction of three forces. Now, what are the three forces? As you can see, there is tension force in the rope. So where should be the tension force? Since the balloon will be stretched upward, this has been pushed upward by air resistance. That means the string is holding the balloon with the ground. So the tension force will be upward or downward? It will be downward. So we will have a downward force of tension, as you can see here. Okay, this is tension force. Then the next force is weight. So where should be weight? Obviously that is downward, so we are going to label that as W. And then there is upthrust. Where should be the upthrust? Obviously upthrust should be upward, the air resistance pushing the balloon upward. Now, so we have labeled these three forces, as you can see here. The tension in the string against the ground, okay, and the weight, and then we have drawn the arrow for upthrust. So you get what? You get 2 marks for this. So let's see how the student has performed this. So let's just going to mark him. All right, so we have tension, that is correct, weight, and of course the thrust force is at the top, so it should not be like that. It should be somewhere here. You can draw it over here. Okay, just to show that this is the force due to air on the balloon. All right, so anyways, you'll get 2 marks for this. Okay, this is the first part. Now we will go to next part, that is part B. So it says calculate the volume, all right, to 3 significant figures of the balloon. So the first thing we need to know is which formula we should use. Multiple things comes to your mind. The important thing is you should write a starting argument for yourself. Okay, now what could be a starting argument over here? As you can see, there are 3 forces acting: the weight, the tension force, and the upthrust, and you know the directions of these 3 forces. So let's just find out the equation for these 3 forces. So we say upthrust is upward, okay, weight and tension force both are downward. So when forces are in same direction, what we do? We add them, and the other force is in opposite direction, so we write it at the other side of the equation. Of course, you know this now. Now, what next you should know? What's the formula for upthrust? The formula for upthrust was F equals to rho GV. What is the equation? Rho GV. Now, so you know that the equation for upthrust. Next, weight is mg. You can write W, you can write mg plus T. So let's write the whole equation over here. Now let's just go back. Now, what do we have? Do we have density? Rho. This is the density. Yes, we have over here. As you can see, it is given to us. We need to find out volume. we need to find out, we already have the weight and tension force. As you can see over here, there is weight and then there is tension force. So let's find out V. So just making V as a subject, as you can see over here, leave V alone and rho into G will come over here. So as you can see, we have made the equation for V as a subject. Now let's just plug in the values. So what's the value for W? We know the value for W, it's given up here to us. So this is the value for W. So we have W as 3.39 cross 10 power 4. We have tension force, so that is added, okay, and divided by density, all right, multiply by G. Okay, just plug in the values correctly, of course. Now here is the important step. You need to be very careful with the addition, because over here you have two different powers. One is 10 power 2, one is 10 power 4. So the command you give to the calculator must be obviously correct. So when you give a proper command, you get 2.84 into 10 to the power 3. All right, that's the answer. Now, how much marks you have for this question? Let's see how much marks we have for this question. So altogether we have 3 marks. How these marks can be given to us? Let's see. First is obviously the starting argument, this one. Is this important to write? It is. Sometime a mark will be awarded, sometime mark will not be awarded. But how does it help you? If you write the starting argument, this will help you to actually have that map in your mind for the next step, like what you should do next. Okay, so sometimes students write the starting argument, they get a mark, sometimes they don't write, but it is always preferable to write. Okay, so you should write, or you can write in the equation form like this also. So in both cases you'll get 1 mark for this. Okay, so you get 1 mark for this. Then you do proper calculation. The correct calculation is important. So all these steps, as you can see, all these steps are very much important. So if there is any conversion required, you should do that also. In this question it was not required. And lastly, the question said that you should give the answer in 3 significant figures. As you can see, we have given the answer in 3 significant figure, so you get 1 more mark for this. So altogether you got 3 marks. All right, now let's see how the student has basically attempted this question. So let me just take you to the solution of the student. Now how he has attempted or she has attempted. Now let's see, the starting argument is there. Okay, fine, so he'll get 1 mark. So 1 mark is awarded. Now second, W plus T. All right, W and T values are there, plus sign is there, correct, equal to density into rho. Okay, density is 1.23, that is 1.23, multiply by 10. We should not write 10. Okay, we should write 9.81 times V. Okay, now altogether there is some mistake. The mistake is in what? The mistake is basically in calculation. Maybe the command is not given correctly to the calculator, but as you can see, the answer is not the one which we got, which was the correct answer. So how much marks this student may gain? He has scored 1 mark for the starting argument. He has lost his mark for the calculation. Okay, and if you see, it is a silly mistake because you've done all steps correctly, but just the wrong calculations, is resulting in the reduction of mark. And of course the last mark will also be lost because the answer is not correct. So altogether, now this student will get what? This student will get just 1 mark in this part. All right, so need to be careful. So let's do now part 3. We say the balloon is released from the rope. Okay, means that initially balloon was at rest. Of course we know that. So remember the point, when the balloon was at rest, although there were 3 forces later on, the weight, tension force and upthrust, now there will be only 2 forces, because when there is no speed or it is not in motion, then there will be no drag force. Okay, so calculate the initial acceleration of the balloon. Let's see, what's the formula for calculating the acceleration? Of course we know that, it's a basic formula. Acceleration is net force by mass. Let's find out mass first. So we need to find mass. using the formula of weight, W equals to mg. Okay, now m is W over g. We have weight given. We have weight given here, as you know. All right, divided by weight, g. So you get what? Let's find out the value for mass. That is 3455.6 kg. Okay, this is mass. Now we know mass, but we need to know now which force we should put as net force. Now I just elaborated a bit that when the object is at rest, okay, at that particular time there will be no upthrust, there will be no drag force acting on it. Okay, here the upthrust is the force due to air on the balloon. Okay, not due to liquid, of course. So means there is no drag force. So that means that there is there are only two forces, that is weight and the tension force. Now finding the acceleration, since the balloon is being taken up by the tension force initially, so let's consider that. So we say the net force will be equals to tension force. Okay, now let's plug the values. So tension force, we know that is 4 into 10 to the power 2 newtons divided by mass we just found, and calculating the value we get 0.115. Rounding off the 5 becomes 0.12. So altogether you have 3 marks for this question. Now let's see, 1 mark will be given to you for writing the initial formula or the equation. The other mark will be given to you for doing all this correct calculation. Okay, and the last mark that you get will be for writing down the correct answer. Okay, let's see how you guys sometime solve such questions. So look at this part. It's the same question, of course. So they say that forward force minus backward force is equals to ma. So somehow the net force concept is written. So we say here this should be rephrased. Okay, then you can see the calculation. After doing this whole calculation, you don't get the correct answer. So again, there is a mistake in calculation and the answer. So altogether, you'll get 0 marks for this question. Part B. So let's see. It says the balloon is stationary at a height of 500 meters. Okay, above the ground. Now a tennis ball is released from rest and falls vertically from the balloon. Okay, now there is a ball which is released, right? Now they say a passenger in the balloon uses the equation v square equals to u square plus 2as to calculate that the ball will reach, okay, will be traveling at a speed of approximately 100 meters per second when it hits the ground. Now here is a point to consider, that this equation can only be used. What were the conditions for? First condition was when A is uniform, means uniform acceleration, and number 2, if you are using A as G, then G must be what? Free fall acceleration. This should be free fall acceleration. So these are the 2 points that we will consider. Okay, now state why the actual speed of the ball, okay, why the actual speed of the ball will be much lower than 100 meters per second when it hits the ground. When the ball falls through air, it experiences upward air resistance against its weight. We know that will be downward, so the weight is downward, of course. Now this is the first mark you get. Okay, as the speed of the falling ball increases, the air resistance will also increase. So what will be the effect? The increasing air resistance will actually decrease the net force. That means weight will be always greater than the resultant force. So you get another mark for this. And lastly, since acceleration is force by mass, that is net force. So it must be less than 9.8 meters per second squared. As the speed of the falling ball increases, the air resistance experienced by the ball also increases. Now, what happens when the air resistance increases on the ball? Basically, the ball's acceleration will decrease. Why the ball acceleration will decrease? Because the net force will decrease. The A, if you are using A as G, then this G must be free fall acceleration. Free fall means it should be equals to 9.81 meters per second. But in this case, what is happening to acceleration? It is reducing. That means the value will be lesser than 9.81 meters per second. How the student has attempted this? We say, as he says that as when the ball will fall downwards, the air resistance acting on the ball will increase. That's correct. So he's going to get 1 mark for this. Okay. What next? Now, due to which resultant force will decrease. That's fine. Okay. Causing a decrease in acceleration. Okay, perfect. So he gets another mark here. And let's see. Now the last one. That is why it will be less than 100 meters per second. If he will get 2 marks. Fine. So he is getting 2 marks, but the third mark will be a little in the doubt, because he is not actually telling the examiner that he knows, the student is knowing about the factor that A in this equation, when the object is falling, A is actually equal to G. Okay, fine. Let's go to the part C now. Part C, they say that before the balloon is released, okay, the rope holding the balloon has the strain of this much. Okay, we have strain over here. The rope has unstretched length. Okay, rope obeys Hooke's law. Show that the extension of the rope is this much. Okay, fine. So just write down the equation for strain, that is extension by length or actual length, whatever you write. Now you have strain and you have unstretched length, means that is L, and this is strain, and they want you to find out extension. As simple. So just make extension as subject. As you can see, plug in the values and you get the answer, and you're supposed to show this, so you get 1 mark for this. Okay, now go to the next part. Calculate the elastic potential energy. Okay, so to find out elastic potential energy, we have the equation as elastic potential energy is 1 over 2 Fe, and there is also another equation as elastic potential energy is 1 over 2 Ke squared. Now, which equation should I use? If I want to go for this equation, the equation number 2, then I have to find out K first using F equals to Ke. And if I want to go for this equation, let this is my equation number 1. So I have all the data. I have force, I have extension, and I just need to find out the elastic potential energy. So I'm going by this equation. That's why, just to save up my time. So let's plug in the values. So the force, which force I'm supposed to consider over here? The tension in the string. Remember, that was 4 into 10 to the power 2 up there, into extension. You just found extension over here. So just plug in the values and multiply 0.115, rounded this to 0.12. Okay, so you get the elastic potential energy. Just quickly, let's see how the student have attempted this part. Basically, now as you can see over here, the strain is fine. Okay, this equation is fine, and just plug in the values correctly, so you get 1 mark. Perfect. Now let's see the other one. Hooke's law is used, F equals to Ke. Then the equation used as, see, elastic potential F equals to Ke. Now here he's a bit confused which equation to find, although he tried to find out K. Okay, because you have 2 equations now. One is for weight, one is for the tension force. Okay, now E equals to 1 over 2 Ke squared is used, but again for some reason there is some problem with the answer, means maybe the calculation is incorrect. So since you're going for choosing that equation of E equals to 1 over 2 k E squared, and for that you need to find out k first, and in that case you need to choose correct force and extension. So maybe that is the reason you lead to some kind of error. So that is why not to go with the simple equation where you have all the data, E equals to 1 over 2 k E squared, and get your 2 marks. The third part says the rope holding the balloon, okay, is replaced now. It is replaced with a new one, but the new rope has same original length and cross-sectional area. Now these points are very important, okay. So now it is replaced with the new one, but importantly it has same length and same cross-sectional area. The tension in the string is also unchanged, okay. Now the new rope also obeys Hooke's law. Good. Now the new rope is made from a material which has lower Young's modulus. Now here is the thing. So state and explain the effect of the lower Young modulus on the elastic potential energy. So first thing, you know the equation for elastic potential and Young's modulus. What was the equation for Young's modulus? We say Young's modulus is stress over strain, as you can see here. Then stress is force by area, strain is extension by length. In the next step you get F into L, A by E. You know this. When you flip this, this will go to multiply, right? Down there you start with this. Young's modulus is E equals to FL by AE. When you see E means Young modulus and the extension, they are inversely proportional, aren't they? So the question is saying that the Young's modulus is lower, means decreased. So what should happen to extension? It should increase. Okay, this is the first point. So write this down, that extension is inversely proportional to Young's modulus. Okay, and you should say that E should increase, the extension should increase. Now relate this with elastic potential energy. So write down the equation for elastic potential energy, that is 1 over 2 into Fe. Okay, now see, extension and elastic potential energy are directly proportional, as you see here. So you said that extension increases, so elastic potential energy should also increase. So you get 2 marks for this. All right.